Today I want to give you a mini lesson on calculating with significant figures. So you have just been exploring with calculating with sig figures. You've been working in the lab and you have made some measurements and you've made some really good measurements. You have massed the liquid in your graduated cylinder and you've got 44.45. There's 4 significant figures there. All of these numbers are significant. You are certain of the 4 and the 4 and the 0.4 and you had to guess at that 5, but even that number that you guessed is significant. And then you made a measurement, a volume measurement, say 56 milliliters, and you were pretty certain of those figures. Maybe you had to guess at that last one, but they're all significant. Now comes the time when I'm asking you to make a calculation with the measurements that you made. Come on in. So now I'm asking you to make some calculations with your measurements. And if you did this calculation, 44.45 divided by 56, you would get a number like 0.79375, and however many digits your calculator would report. And in math class, you'd raise your hand and you say, how many digits do you want me to report? And your math teacher would say something like, give me 2 digits to the right of the decimal. And that's just kind of arbitrary. He did that without any rhyme or reason. Well, this is science class, and you're going to know how many digits to limit it to. In fact, if you really want to impress your math teacher, when you get a big number like this, you can look at the numbers that you used to make that calculation and know for yourself how many digits to write. I didn't tell you how to calculate with significant figures because I wanted you to struggle with it for a little bit so that you would realize its importance. And in fact, I did have some students come up to me and say, I got this big long number, should I write all these digits? I'm like, thank you for asking. I'm going to explain that in just a minute. So here I am explaining. Okay? It's really just a 2-step process. First of all, just go ahead and calculate as usual. And then when you get your answer, then you have to figure out how many digits to report. And this is your mantra right here. I've worded this as carefully as I can, so I do want you to have this in your notes. Your answer can only have as many sig figs as the term with the least number of sig figs. That's said pretty concisely. So you're going to have to round. Now, let's do a quick example. You all have your calculators handy, so we'll do this together. Let's just say we're calculating the volume of a fish tank. And say it's 10 by 11 by 12. That's just like 3 random numbers that I've got there. Can you all get your calculators? And step 1 is just to calculate as usual. What is 10 times 11 times 12? No, that's okay. 1,320. Okay? In order to figure out how many sig figs your answer has, we have to go back and look at how many sig figs each term has. So this is where the last lesson on determining the number of significant figures is important. How many significant figures are in the number 12? 2. How many significant figures are in the number 11?
2.
How many significant figures are in the number 10?
2.
1. Right, because this 0 is just a placeholder. So our answer can have only how many sig figs?
5.
Your answer can only have as many sig figs as the term with the least number of sig figs. Which is the term with the least number of sig figs? 10 is the term with the least number of sig figs. How many sig figs does that have?
1.
My answer can only have 1 sig fig. Do you know how to write? So this has got, right now it's got how many sig figs? 3. It only can have 1. So I have to round. So in order to round, here's what I do. I say, okay, I can only have one sig fig, so I underline that first one to this first one here, and then I look to the right of that and to decide whether to round up or round down. This is a 3, so is my number going to stay 1 or is it going to round up to 2? It's going to stay 1. So if I round this number to 1 sig fig, that number becomes 1,000. And some students, they'll go, wait a minute, you just threw away all that good stuff. I had to, because this number was not very significant. And it affected the answer. Okay? Let's do another example. Let's do one like your density calculation. Say we are measuring the density of water, and we mass the water at, I hope this works out with a lot of numbers in your calculator. Let's just say 23. 23 is the mass in, maybe, no, if we did it on a triple beam balance, it would be like 23.14 grams divided by some volume measurement. If it's water, oh, it's probably going to come out to, I don't know, 24. And if we use the 250 millimeter graduated cylinder, then this is all the precision that we can get, 24. Go ahead and do that in your calculator and let's see what you get. All right, can you say that again? 0.96416666667. Isn't that what you mean when the calculator goes 666666666 and it puts a 7 on that last one? Only because it can't show any more digits, right? Are you going to write this on your paper? No. Are you going to be proud of that? No. All right. Stop the video and tell me how many digits you should report based on these rules. All right? So we know we're not going to have any of these over here. We know we're not going. Somewhere we have to stop, right? Somewhere we have to stop. And the rule is you can only have as many sig figs as the term with the least number of sig figs. Let's take this one step at a time. Diego, how many sig figs does 23.14 have? 4 sig figs. How many sig figs does the number 24 have? Marcus. Can you see the number, Marcus? I saw you're looking behind. You can't see. Okay. The number 24, how many sig figs does that have? 24. All non-zero numbers are significant. Are these numbers non-zero? This is not 0. This is not 0. So they both must be significant. So how many sig figs are there? 2. Okay? Your answer can only have as many sig figs as the term with the least number of sig figs. What's the term with the least number of sig figs? 2. All right? So my answer can only have 2 sig figs. So this is what I do. I go to my answer and I'm going to draw 2 lines underneath the first 2 digits of my answer. And then I'm going to look to the right of that and to decide whether the 6 is going to go up to a 7 or stay a 6. And it's going to stay a 6. So I go from an infinity number of significant figures. I'm going to have to round that to 2 significant figures. So 0.96741666667 becomes 0.96. And if I'm proper, this is actually a measurement in grams per milliliter. Okay? It's not that bad, is it? Now you can impress your math teacher by not asking her, how many digits am I supposed to write?